Hey guys, this is 1.2 of your logic section, formulas of classical logic. Classical logic, I just mean the propositional calculus we learned last time. So we're going to learn a little bit about how the formulas of that work. First, the connectives, I'll review those, what they mean. Remember, when I say what they mean, this isn't exactly what they mean. So every time you see a not in English, wouldn't absolutely always coincide with one of these guys. But basically, that's what they're talking about, and we'll see today how they work, and that should clarify it. So this little guy right here means not. Anytime you put in front of something, that means whatever that thing you just said, not that. So if you say something like not P, and P is ice cream is delicious, not ice cream is delicious. This guy right here means something like and. All that does is put two things together. So ice cream is delicious, and let's say I don't know, cherries are also delicious. P and Q, both ice cream and cherries are delicious. Then this wedge, it kind of means something like or. So let's say P or Q, ice cream is delicious, or cherries are delicious. What it really means is means at least one of these two guys. At least ice cream is delicious or cherries are delicious. Possibly both, but at least one. This gentleman right here is kind of like an if-then. So if I say, let's do it. Make that R. Yeah. If R, then S. Let's say that. And let's say R is, if it's a rainy day, then the street will be wet. Something like that. Something like that. And then this guy right here, these three lines, there's if and only if. This is something like, it's the if it is a triangle, if and only if it's a three-sided figure. Let's say let's do E for three-sided figure. So if you have a triangle, then you have a three-sided figure, and if you have a three-sided figure, then you have a triangle, and if it's not a triangle, it's not a three-sided figure, etc., etc. And remember, A, B, C, the capital letters, those are formulas. So like I could say A is equals P and Q, something like that. And the lowercase ones, those are all propositional parameters. Alright, so remembering that, let's talk a little bit about how they work. The first one we'll talk about is the either or, A or B. The first thing to note is that this is how you get a valid argument from A or B. A wedge B, right? So you'll say something like A or B, not A, therefore B. So why does that work? Well, A or B means something like this. Either you're in A or you're in B, right? You're in one of those two things, and you can't be outside of it, right? So either you're in A or in B, but not outside of both those things. Well, if you're not in this whole A thing, and I know that I'm not outside of it because A or B, right? If I'm not in this A thing, then the only place for me to be is over here, hanging out in the B side, right? So A or B, not A, therefore B. That's the valid way to get an argument out of that. An invalid way, however, would be something like this. Either A or B, you're somewhere in here, right? You are in A, therefore you're not in B, right? So that would mean something like this. You are in A, therefore you're over here. You're outside of the B. But that's not necessarily true. I could be inside of the A and also be inside of this little B area right here too, right? So that is an invalid way of making an argument here. In other words, that doesn't work. Maybe you're outside of B. I don't know. Based on this argument, you haven't proved that. That's what that means. So let's take some examples. Either you're going to eat or you're going to sleep. You are not going to eat, therefore you will sleep. So either you're going to eat or you're going to sleep. You're somewhere in one of these circles, possibly in both of them, right? You're somewhere in here. You're not going to eat, so you're outside of this pink one. Well, if you're outside of the pink circle and you're somewhere in these circles, then this must be where you're at. You're in the sleep area, right? That is a valid argument. But let's change it up a little bit. Either you are going to eat or you're going to sleep. Same thing. So either you're somewhere in here. Either you're going to eat or you're going to sleep. You are going to eat, right? You're in here. Therefore, you will not sleep. Well, not necessarily. I'm in this pink circle, and the pink circle overlaps the blue circle, and I said that this is a possibility, so possibly I'm here, possibly I'm not, but of course I am going to sleep and eat today, so it makes a lot of sense. Here's an example of something. Let's change it out. You can see a little bit better what it would look like. Either you are Clark Kent or you are Superman, right? You are Clark Kent, you're in this Clark Kent circle, therefore you're not Superman. No, that doesn't make any sense, right? So this is invalid. I wrote the name of the fallacy. It's called affirming an alternate. These are alternates, right? Alternatives, right? They're alternates. And affirming is to say yes, right? So you're saying A is true, but you don't have to know the terms. You just have to know what's valid and what's invalid. There is one special case, however, and the case is when the two terms are mutually exclusive. So pass and fail are mutually exclusive. You can't pass and fail at the same time. So let's say this is like a black hole in here, right? You can't be in here. This doesn't exist, right? So if you say either you're going to pass this class or you will fail it, and let's switch to green, because green's a more positive color. Green means go, red means stop. So either you are going to pass this class or you're going to fail this class. You're in one of these two sides, and there's nothing in here. But I don't know that based on this. I just have to know, by the way, this is, these are mutually exclusive, so there's nothing in here. I have to know that. Either you're going to pass this class or you'll fail it. You're going to pass this class, so I am in here. Therefore, you will not fail it. I know that's true because this doesn't exist, right? So if the two are mutually exclusive, meaning they can't be together, then this argument works. But you have to kind of know that. All right. The next connective is the and sign, A and B, right? By the way, let's go back one. The little wedge or is called a disjunctive. You can think of that the or. This is like a wedge splitting the two apart, and then this is just the opposite of that, right? And putting them together. Well, A and B, when you say A and B, what you're saying is you are in this area right here, right? You're not in the just A area, you're not in the just B area, you're not outside of the area, you are only in the A and B area. So what kind of conclusions you can get from that? Well, you can get the conclusion that A is true because you're in the A area, and that B is true because you're in the B area. I should have said these little dots, 3 dots, that means therefore, by the way. So, therefore A and therefore B. That sounds like super obvious, right? A and B is true, therefore A is true, therefore B is true. When it's not so obvious is when you negate that, when you say not A and B. If you say not A and B, what you're saying is you're not in this area right here. But look at all the different places you could be. You could be outside here in A, you could be outside here in B, or you could be out here and neither one of them are true, right? So you can't say, if you have not the case that A and B, you can't say therefore not A, or you can't say therefore not B. You're not sure which one it is. By the way, the parentheses are important, kind of like math, right? It's not, this isn't the same thing as not A and B. Not A and B would mean you're not in this A, but you are in this B side, so you'd be right here. That's different than saying not A and B. That means you're not neither one of those two, right? Kind of like the negative sign. If I said negative 1, now let's do variables. Negative x times y. Well, I suppose that actually does work, right? Because the negative goes in here. Negative x times y. Yeah. Never mind. That doesn't work. Well, let's say that what plus, right? That would work. Negative x plus y is different than negative x plus y. Is that right? That's right, right? Because 2 plus, let's say x is 2 and y is 3. 2 plus 3 is 5, negative 5. But negative 2 plus 3 is 1. Yeah, there you go. So, not this one. Never mind. It's kind of like this right here. Exactly. Alright, well, let's look at an example of this. You are both Clark Kent and Superman. So you're in this zone right here. Therefore you are Clark Kent. Therefore you're in the Clark Kent bubble. Therefore you are Superman. Obvious conclusion. But here's the unobvious one. I didn't eat bananas and peanut butter. So you're not in this zone right here. let me do, this might be a little confusing because I used red for something different, but let's say this red is this X is going to say you're not in here. I didn't eat bananas and peanut butter, therefore I didn't eat bananas. Oh, not necessarily, right? You're just saying that you're not in both of them. So you might have eaten bananas, you might have eaten peanut butter, maybe. Maybe you didn't eat either one of them, possibly, I don't know. You don't know based on this statement. I didn't eat bananas and peanut butter, in other words. Therefore invalid. Alright, if A then B is probably the most confusing one. The material conditional, this little guy right here, if A then B. Here's, before I show that, here's kind of what you're saying, right? You're saying if you're in the A circle, then you're also in the B circle, right? So I know that this is true. I know that if you're in the A, then you're in the B. So you're possibly in here. But think about this too. If you are in the A, then you're in the B. But what if you're already in the B, but you're not in the A? Well, that's okay, right? Let's say I want to say, if it rains A, then the street will be wet B. Right? Well, the street can be wet without it raining too. All I'm saying is if it's raining, then the street will be wet. So if you're in the A, then you're in the B, right? But maybe it snowed or something. I don't know, something like that. So if B is true, then this statement it can still be true. If A is false, if both of them are false, in other words, then this statement can still be true. Let's say it did not rain and the street's not wet. It's still true that if it rains, then the street is wet. The only thing it can't be the case that if it rains and the street is not wet. That's when this is false, right? So there's only one of these possibilities where this is false, and it's this one. If you're in the A and you're not in the B. Alright, so let's look at what kind of conclusions can you draw from that. Think about the kind of conclusions you can draw from that. Let's say I say if A then B. Well, if I'm inside of the A, does that mean I have to be inside of the B? Yeah, that's what this whole statement means, right? So if A then B, A, well, if I'm A, I can't be in here, so therefore I must be in the B. But here's a little more confusing one. If A then B, let's say you're not inside of the B. Can you make a conclusion from that? Well, look, there are 4 possibilities, right? 1, 2, 3, 4. And you're not inside the B. I've canceled out 2 of those possibilities. And I've said that this isn't a possibility at all, ever, right? So then you're left with 1 left, right? So if A then B, you're not inside of B, therefore you're not inside of A as well. Alright, so those are valid ways of getting a conclusion from that. There are a couple of invalid ways of getting conclusions from that. The first one is if you say if A then B, let's say you're in B. Does that mean you're also in A? Well, let's look at our options, right? Let's say you're in B. Well, I have 2 options here. One, I'm outside of A. One, I'm inside of A. So if I have if A then B, and I am in B, that doesn't necessarily mean that I'm also in A. So this is invalid. If A then B, B therefore A. That's invalid. And then one more invalid way of arguing, if I say if A then B and I say I am not in A, can I get a conclusion from that? Well, let's say I'm not in A. That means I'm not in this one and I'm not in this one. Does that mean I'm not in B? Well, not necessarily. I could be in B. Right? So I don't know. If I say not A, I don't know if I'm in B or not. So another fallacy that people make, if A then B, not A, therefore not B. And that looks hopefully that looks pretty obvious when you're looking at the picture like this. It gets a lot less obvious when you're actually doing work. I have an example that I'll give you guys sometime later of this exact error right here that almost everybody gets wrong. All right, well, let's look at some examples. If you have Coke with Pop Rocks, then your stomach will explode. By the way, this is the big urban legend when I was a kid. People were all afraid that they were going to be eating Pop Rocks and one day someone would shoot Coke down their mouth and your stomach would explode. I don't know where it came from. It's not true. You can try it yourself. Maybe you shouldn't try it. What if you die? Yeah, if you die, then it's not my fault. Don't do it. If you have Coke with Pop Rocks, then your stomach will explode. So remember what we're saying is if you're in this circle, then you're also in this circle. So you can't be in this side right here. This is wrong. This is X. Wrong. So everything else is fair game. That's all that statement says. Is that you can't be in that side. So this is okay. I won't do an X for that. This is okay, and this is okay. You had Coke with Pop Rocks. You're in this circle. So I know I can't be here. Where can I be? If I'm in this circle and I can't be here, I have to be in the stomach explodes too. Therefore, your stomach explodes. So that's valid. Valid. Modus ponens, by the way, is a Latin term, meaning I'm not sure what. You don't have to know the Latin terms. If you have Coke with Pop Rocks, then your stomach will explode. Your stomach did not explode, therefore you did not have Coke with Pop Rocks. Let's draw that red X one more time so we remember that this is not viable. You're not allowed to do that, and you can't do this. This is okay. I should be doing checks the whole time. This is okay, and this is okay. So your stomach did not explode. You're not in the blue. There's only one place you can be, right? Right here. So outside of the blue and outside of the pink. Your stomach did not explode, therefore you did not have Coke with Pop Rocks. Sweet. Modus tollens. If you have Coke with Pop Rocks, then your stomach will explode. So let's do it again. Check. Oh, that should not be there. This should say stomach explodes. Check. I'll have to fix that. And the one place that you can't have it is right here. No. Alright. If you have Coke with Pop Rocks and your stomach will explode, your stomach exploded, so you're in the blue. If you're in the blue, therefore you had Coke with Pop Rocks. No, that's actually not where you can be, right? You have to be outside of here. If you have, wait, is that right? Your stomach exploded. Oh no, so you're in the blue. Oh, sorry, wrong way. Yeah, you're in the blue, your stomach exploded. This thing's throwing me off. Your stomach exploded. Are you in here or in here? You don't know, right? So you could be in Coke with Pop Rocks, or you might not be. So that is invalid. Here's a way of making it make sense. If you have Coke with Pop Rocks, then you consume sugar. Now that's what the other thing says on top of it, by the way. You consume sugar, therefore you had Coke with Pop Rocks, right? So this is just a way of breaking out. Same format, but it sounds a lot more obvious. If you have Coke with Pop Rocks, then you consume sugar. Well, there's plenty of ways to consume sugar, right? So just because you consume sugar doesn't mean you had Coke with Pop Rocks. Same thing up here, although since nobody ever talks about your stomach exploding, you think Coke with Pop Rocks and stomach exploding the same way. But that's not what this statement says. And if you think about it, maybe you swallowed a grenade. I don't know, something like that, right? All you're saying is if you do this, then you're going to do this. So, affirming the consequent. This is, by the way, the P is the antecedent and the Q is the consequence. The consequence, what happens, right? You can't say yes to the Q and therefore get yes to the P. Alright. If you have Coke with Pop Rocks, then your stomach will explode. So, in other words, you can't have Coke with Pop Rocks without your stomach exploding. You did not have Coke with Pop Rocks. Let's do our green. This is the last time we're going to have to do this, I promise. You did not have Coke with Pop Rocks, so you're not in the pink circle. Therefore, your stomach did not explode. So you're out here. Well, no, not necessarily. You could be right here, right? Let's give you a different example. Here, it worked this time. If you have Coke with Pop Rocks, then you consume sugar. You did not have Coke with Pop Rocks, therefore you did not consume sugar. That clearly doesn't make sense, right? There are plenty of ways to consume sugar. So this is another fallacy. People deny the antecedent. They say not P, and then they think they could say not Q. Right? A very common mistake, by the way. A lot of people make that mistake. Finally, this one we won't spend a lot of time on. If A, if and only if B. A, if and only if B, you mean if you're saying if you're in the A circle, then you're in the B circle, right? This isn't A and B. You're not saying that for sure you have A and B. You're saying if you have the A, then you have the B, which means if you don't have the A, then you don't have the B. So also you can be out here. That means you can't be here with only A or here with only B, right? So here's a valid way of making conclusions from that. If you have if A then B, So right, if you're in the pink, then you have to be in the blue. So there's, you can't be here. And you have if B then A. So the opposite, right? If you're in the blue, then you have to be in the pink. You can't be out here. Then you have A if and only if B. Another valid way of getting a conclusion from there is saying if you have if A if only A if and only if B, and you know A is true, then you know B is true too, right? Because you know if these are your two options and you know that you're in here in the pink, then you know you have to be in the blue too. And here's another way, it's the exact opposite. A if and only if B, if you have these two are your only options and you're outside of the pink, then you got to be outside of the blue too, right? Here's a little example. Triangle, three-sided figure. You have a triangle if and only if you have a three-sided figure. So you can't have triangles that are not three-sided figures. You can't have three-sided figures that are not triangles. The only options that are valid are both triangle and three-sided figure, and neither triangle nor three-sided figure. So here's your first argument. A thing is a triangle if and only if it has three sides. This thing has three sides, therefore it is a triangle. By the way, most of the time I'm going to take this if and only if, and I'm just going to make it like this. If. You may have seen this in math. If. Here's another one. A thing is a triangle if and only if it has three sides. The thing is not a triangle, therefore it does not have three sides. Right? So it's a triangle if and only if it has three sides, so either this or this. It's not in here, so it's got to be out here. And that's it.